Welcome, my dear students. We are going to study the calculation of lattice energy. The calculation of lattice energy by Born-Landis equation and Kapuscinski equation. First, we see the Born-Landis equation. Lattice energy U for an ionic compound can be calculated theoretically by applying Born-Landis equation. U is equal to N A E square Z plus Z minus upon R in bracket 1 minus 1 upon N. Here N is a capital, N is a Avogadro's number, E is the charge of an electron small e, Z plus Z minus are ionic charges in capital, N is a empirical number small n, which is a repulsive parameter, varies from 8 to 12 depending upon the ions in the crystal. Small r is the internuclear distance and capital A is the Madelung constant, which depends upon the geometry of the crystal lattice. For some compounds, the theoretical calculation on the Born-Landis equation are fully in agreement with the obtained from Born-Haber cycle. For many compounds, values differ as ions are not rigid spheres as they undergo distortion due to the neighboring ions. Numerical, for example, calculate the lattice energy for MgO, magnesium oxide crystal using the following data. Small r is equal to 2.10 angstrom unit, N is equal to small n is equal to 7, capital N is equal to 6.02 10 raised to 23, capital A is a 1.74, E small e is equal to 4.8 into 10 raised to minus 10 ESU electron subunit. Then solution in a MgO, Z1 is equal to Z2 is equal to 2, therefore Z square is equal to 4. U is equal to N A E square Z square divided by R in bracket 1 minus 1 upon N. U is equal to minus 6.02 10 raised to 23 into 1.74 into 4.8 10 raised to minus 10 bracket in bracket square and into a 4 upon 2.10 into 10 raised to minus 8 into 10 raised to 10 in bracket 1 minus 1 upon 7. If this is solved, then U is equal to minus 3940 kilojoule per mole. The lattice energy for that magnesium oxide crystal is U is equal to minus 3940 kilojoule per mole for given data. Another that is a equation, that is a calculation for lattice energy, Kapuscinski equation. For a theoretical calculation of lattice energy of an ionic compound, it is necessary to know the crystal structure and the interionic distance. Kapuscinski equation overcomes this limitation by making some assumptions. Madelung constant A and repulsive parameter small n are taken as equal to average values. It is always assumed that interionic distance can be taken as sum of anion and cation radii R minus and R plus, in small letters R minus and R plus. For a binary ionic compound, Kapuscinski equation in the simpler form as UL is equal to C into V into Z plus into Z minus in capital letters, then upon R plus R minus R, it is in small letter, where V is a number of ions, in the formula unit. That is 2 for sodium chloride, 3 for Mg F2. C is a constant equal to 1.079 10 to 5 radii in a picometer, and UL is in a kilojoule per mole. R plus and R minus are radii of cation and anion. Capacitance equation is useful for rough calculation of lattice energy of ionic compounds for which crystal structure is unknown. This equation emphasizes two main aspects of lattice energies. First aspect, that is, lattice energy increases with increasing charge on the ions. And second aspect, that lattice energy is larger for smaller ions. Numerical, for example, calculate the lattice energy of sodium nitrate from the following data using capacitance equation. Given that the radius of Na ion, that is Na plus, is equal to 97 picometer. Radius of nitrate ion NO3 minus is equal to 189 picometer. Then solution: in a sodium nitrate NaNO3, the number of ions Re is equal to 2. The value of constant C is equal to 1.079 10 to 5. UL is equal to C into V into Z plus into Z minus upon R plus plus R minus. Then is equal to substituting value of this and gives that the value of C, V, Z plus and Z minus, R plus and R minus, then gives the UL 1.079 10 to 5 into 2 plus 1 into minus 1 upon 97 plus 189 is equal to minus 2158 10 to 5 upon 286. Then UL is equal to minus 754.545 kilojoule per mole. Means by capacitance equation we can calculate the lattice energy for sodium nitrate for given data. The UL is equal to minus 754.545 kilojoule per mole. Thank you.